So here's what some data can look like. This was collected from 10 students, and they answered questions on what gender do they identify as, whether or not they smoke, if they could win an award, would they want an Olympic gold medal, Academy Award, or Nobel Peace Prize, how many hours per week do they exercise, how many hours per week do they watch TV, their GPA, they took their pulse over 1 minute, and then birth order, meaning like this is the fourth born, so they have 3 older siblings. So what we want to do when describing data is investigate the cases and the variables that are involved. So the cases, those often answer the question of who is part of the survey. And this is often going to come through from our data, it's the rows of the data. So like for us, in terms of who did we survey, as I described, it was 10 students. So it's that each row is a student. So like ID number 1, this is a single case, and it's just a single student, and this is how they answered for each of the questions. So the idea is with the case, if you have the row, then you can see all of the answers that match up with the same person or thing, depending on the data. So for us, the cases are each of the 10 students. And with cases, if you can throw in a sample size, that's always a good idea. It gets more descriptive with the data. The variables are often the what of the data. What was asked? What was surveyed? And this is going to come through from the columns of the data. So we have all of these different columns, and as you can see from kind of the title of each column, this is describing the variable that was collected. So for our variables, we have, all we can do is just grab the titles of each column. We were told about their ID, which is kind of a variable. It's not like something that was actually surveyed from them. Usually it's just assigned from the researcher. So ID can go back and forth of whether or not it's actually a variable, but these definitely are. Gender was collected from each person, smoking habits, award they would like to win, hours of exercise, hours of TV, your GPA, pulse rate, and birth order. So with all of these variables, what we want to be able to do is describe what type of variable is it. Because as you can see, answers come in different forms. And the biggest difference between the forms that we could see here is numbers versus words. And we want to be able to tell the difference because then that will change what we calculate from it. So this goes down to types of variables. So if you have all of our variables, it branches into 2 types, numerical versus categorical. And some words that are used in place of numerical, sometimes it's called quantitative, and categorical is sometimes called qualitative. The main difference between these is numerical data, I mean it's in the wording right there, this is where we have numbers. And categorical is where we have words, or sometimes it's pictures. We want to be able to tell the difference between these two. So if we go back above, kind of look at describing further these variables that we have. So ID is kind of a special one, so let's put that one on hold. But gender, they're answering male versus female, so that would be categorical. Whether or not they smoke, they're answering in words, yes versus no, that would be categorical. Awards, they're also answering in words. Then when we get to exercise, they're answering with a numerical value, something that they measured or counted throughout the week. So this would be numerical, TV would also be numerical, GPA would be numerical, pulse, numerical. Birth order we're going to put on pause for a moment, just because it is a little different. Because in terms of reading it, like with this number 130, this is 130 beats per minute. Like it is a numerical value with some units to it. This isn't like one birth order. We would say this is like firstborn. So rather it's kind of describing their placement, and that's a little different in terms of numerical. So we'll jump back to that after we kind of go into these further branches here. Continuous versus discrete numerical values. The difference between these, continuous we often say is measured, where discrete values are counted. So examples of continuous data could be like if you're measuring someone's weight or their height. The idea is, like, say we use weights. If we gather their weight, it's it kind of depends on how specific the scale we're using is, but we could get to a certain number of decimal places of accuracy here. So let's say someone weighed 124.38 pounds, someone weighed 230.51 pounds, and we could have someone that weighed 124.39 pounds, so very close to that first person. And the idea is, if we made a number line of these values, so say we had 124 pounds, 125 pounds, 126, we can land anywhere on this number line. Like where someone was 124.38, someone was 124.39, right next to them. And we could have someone that was 125 pounds, or we could have like 125.5 pounds. The idea is that we could land anywhere on this number line, depending on how descriptive we got with those decimal places. Whereas with discrete data, an example of this would be if I counted the number of students in each of my classes. It would be like one of my classes has 24 students, another has 31, another has 26. The idea being, if I count the number of students, I could count using my fingers. I can count 1, 2, 3, 4, so on and so forth. The idea being, I wouldn't have 24.38 students. I won't have decimals after these, because we can't have a decimal of a student. So when we have a number line, for this idea, say we have our 24 students, 25, 26, I can have 24 students, or I could have 25 students, or I could have 26, but I wouldn't be able to land in between. So the idea is I can only land on specific spots on a number line with this, whereas with continuous, we can land anywhere. So that's the difference between continuous and discrete. So if we go back to our numerical variables up above, and this can be kind of tricky from data, like GPA is definitely continuous. GPA is calculated and we can land anywhere on the number line with that. Pulse rate, definitely discrete. You're not going to have, it would be pretty tricky to grab like a third of a heartbeat when you're counting how many beats per minute. So with that, we'll probably have discrete number of beats per minute. With exercise and TV, it gets kind of tricky because it depends on how they answered. Like this looks like they rounded. But if we're asking like average number of hours per week of exercise, I mean, you technically could have gone to the gym with a stopwatch and calculated it to a certain number of decimal places. So where everyone answered like this, maybe this person could have answered 4.738, like they could have put those decimal places. So this is kind of difficult to tell. But these, definitely. But with exercise and TV, it would just kind of depend on how the question was asked. Like, were they asked to round to a whole number? Because then that would make it discrete in terms of how it's presented. With categorical variables, there are kind of these sub-branches of that as well. There's just regular old categorical, which you don't even need to call it regular categorical. This is just categorical. And this is where you answer with words or images, so like yes, no, or maybe we ask about the weather and we say, okay, it's rainy, or it can be sunny. We can even have pictures, so like if we did the weather, we could use the image for rain, and we could use the image for sunny. That's just regular categorical. Ordinal is this kind of subcategory of categorical, and this is where we see this first, second, third coming through. We have this kind of place value where is a number in there, but really the numbers are creating categories in the end. It's creating this first place category and second place category. So with birth order, this would actually be categorical in that it's ordinal, because there are a certain number of firstborns, secondborns, so you're fitting this category, but it is denoted by a number. So that's a little tricky one where it appears numerical, but is actually categorical. We also place the identifier under categorical. So if we have some ID number, or like if we used your G numbers for PCC, then that would be considered categorical. So this would be categorical where it's an identifier. So this is how we can describe the cases and the variables, and with variables we always want to take it a little further of, is it categorical versus numerical, because that'll change what we can calculate. What we're going to talk about next is, like with categorical where it's giving us words, we can talk about proportions, meaning like what percentage of the 10 students are male. So we can create a percentage out of how many are male out of the whole group of 10. Whereas with numerical, and given that this is a math class, there's so much we can do with numerical. We're going to calculate all sorts of things. We can take the average number of hours of exercise per week. We can go in and find the median. We can start calculating values. So that's where we're going to move on to the next page.